Hello, I'm John Nightingale, a director at JCT and the Symposium host. Now, the 25th JCT Traffic Signal Symposium was an online event this year, and I'm delighted to bring you a recording of one of the presentations. Now, these recordings would not have been possible without the support of a select group of our event partners. So our thanks go to the Institute of Highway Engineers, ITS UK, keepadistance.co.uk, Siemens Mobility, TWM, and of course, our media partner, Highways News. Please check out their short videos, which will tell you about some of the products and services that they can provide. Now, I hope you enjoy this presentation, and we would love to see you in person for our 25th anniversary event in Nottingham Trent University in September 2021. Hope you enjoy it. Thanks.
Thank you, John. Hi, everyone. Today, I'm going to briefly present on the fascinating topic of bus priority and a piece of research that I've undertaken recently for my master's dissertation, studying the effectiveness of applying a weighted level of priority using the new bus priority feature within MOVA 8. As an overview, in this presentation, I'm going to cover what the bus priority feature within MOVA is, how I gathered my data, the results that I got, what my recommendations are as a starting point for on-site implementation. The bus priority feature within MOVA is a new addition with MOVA 8 that allows the users to prioritize select vehicles during the stop and delay optimization process. Once detected, a vehicle is assigned a unique stop penalty value, higher than that of general traffic, so that MOVA recognizes that it's more important to either hold the green for the longer or to cycle round quicker to serve that vehicle quicker. This is an alternate method of prioritization compared to giving absolute priority, whereby fixed green time extensions are applied, and instead allows MOVA to decide whether green extensions are beneficial or not. It's worth noting as well that the feature is only active when the junction is undersaturated. Once the junction is recognized to be oversaturated, the normal capacity maximizing algorithm takes over. To research the effectiveness of the feature, I needed to gather a lot of data in a relatively short amount of time, so I opted to use Vissim and PCMOVA as a test bed. As can be seen in the slide, I created 3 hypothetical sites, all with increasing complexity. For test site 1, I created a very basic 2-stage junction. For test site 2, I made a 3-stage crossroads junction with an opposed right turn. For test site 3, I further edited test site 2 and added an additional opposed right turn and had 5 stages, enabling the automatic stage selection feature within MOVA 6MRR. Then, for each junction, I ran a series of different scenarios, testing out different weighting factors and different combinations of competing priority. The feature allows of a value between 0 and 10,000 to be selected for your weighting factor, so I chose to work in increments of 2,000. So you got 2,000, 4,000, 6,000, etc. For test site 1, it was quite straightforward. I first had bus priority solely on one arm, testing each different weighting factor. Then I tested it with bus priority, competing on both arms. Test sites 2 and 3 followed a similar sort of method, where I first put bus priority on the main road only, then tested them with it only on the side road, and then finally with bus priority competing on the main road and the side road. Now comes the interesting part, the results. The graphs here firstly show bus journey time comparisons, with each line showing a different scenario tested, and the results for an approach. So you can see the results for approach A when using equal priority, and then below it the same scenario but for approach B. And for network delay, you can see the 2 scenario tests. As you can see, bus priority works. At test site 1, once bus priority was applied, there was up to a 15.4% reduction in bus journey times, which, when you consider that the baseline is standard MOVA with no priority at all, is quite staggering. Especially when you look at the overall network delay, which also reduced by 14% when priority was applied to both approaches. Very interestingly and surprisingly, when bus priority was only applied to one approach, the results were identical as weighting factor increased. And moreover, you can see that as the bus weighting factor increases, when using competing priority, network delay begins to increase. There's no benefit to the bus. So to summarize test site 1, 15.4% reduction in bus journey times was achieved, along with a 14% reduction in overall delay. But there were no notable differences as the weighting factor increased. For test site 2, the results started to get more interesting again. I split the results up into directions of travel, so the east and westbound journey times are the main road and the southbound is the side road. The graphs then show the results for each approach with the different scenarios tested. As I've got time restraints, I'm only going to cover the standout points in this presentation, but there are a full set of results available in the paper. You can see from the eastbound and westbound journey times that once bus priority is applied to the main road only, there is a sudden decrease in bus journey times, and to coincide, the bus journey times on the side road increase, as you might expect. If you apply an equal and competing level of priority to the approaches, again, the main road sees initial benefits, but then either levels off or becomes worse. But the side road doesn't see any significant betterment or worsening. Applying side road priority provided little to no benefits to bus journey times, but did make the bus journey times worse on the main road. The network delay, again, you can see that there was an initial sudden overall improvement when bus priority is applied, either to the main road or equally. So, to briefly summarise test site 2, once a weighting factor of 2000 was applied to the main road, there was a significant decrease in bus journey times, east and westbound. Interestingly, once the side road received priority, it didn't receive any notable benefits or disbenefits, but it did have a negative impact on the main road. And the trends show that applying an equal level of priority across the approaches seems to strike a balance of improving the main road, but improving the side road, but maintaining the side road performance. The results have shown again that applying bus priority not only benefits buses, but also improves overall network performance. And I'll come on to my thoughts on the reasoning for that a little later. Now, the results for test site 3. In a very similar way to test site 2, applying bus priority to the main road had significant benefits east and westbound, with savings up to 7.5%. And again, as before, when you do this, side road journey times increase. However, what does differ this time is when priority is only applied to the side road. Bus journey times improved by just over 6%, but again, the main road suffered as a consequence. Then, with network delay, you can see that the initial application of bus priority provided significant benefits to all users, with delay reducing by just over 4%. And similarly to before, side road priority increases overall delay. So the take-homes from test site 3 are that again, significant improvements can be seen on the main road when it's prioritised. Applying priority to the side road improved journey times by just over 6%, but had a negative impact on the main road. And again, a modest level of equal priority provided significant benefits to all users. So what have we learned from all this? All 3 sites have shown that it's possible to reduce the overall delay in a junction by applying a weighting factor to buses. The reason for this, I feel, is for 2 main reasons. Buses have a slower rate of acceleration than cars, so once a bus has stopped, it takes it much longer to get going again, so it's much more beneficial to keep it moving in the first place. And second, if the green's held for a bus, there are likely to be vehicles in front of that bus that will get through, or a platoon that will follow the bus through that might not have got through before. So in holding for the bus, you get the vehicles through that are stuck behind it as well. And because of that, this approach to prioritisation could equally be applied to HGVs and may yield similar improvements to junction performance. We've also learned that applying an equally modest level of priority across all approaches strikes a balance that allows everyone to benefit. It may not be the greatest results for the main road, for instance, but the side road doesn't suffer. Thirdly, we've learned that, maybe most importantly to a lot of the people watching this presentation, the solution is relatively cheap. If you already have a MOVA site or a VA site with SD loops, convert it to MOVA and use your SD loops to profile vehicles. Or if you have an existing MOVA 8 site with access to bus inputs, use the feature, as the cost-benefit ratio would be huge. The ability to improve junction delay by up to 14% on top of your normal MOVA benefits with a click of a button is an opportunity that just shouldn't be missed. Now, recommendations for where to start on site. The research that I did showed that there was a significant improvement when applying a weighting factor of 2000 or up to 4000. After that, the results weren't significantly different. So I'd suggest as a starting point on site, start with 2000 on all approaches. What you could also see from the results, what was on the main road, there were instances where applying a high level of priority benefited buses, didn't have too much of a negative impact on other users. So you might want to consider that if you had a bus with a high schedule deviation, it might benefit from a one-off high weighting factor. So you can essentially apply different weighting factors to vehicles as your policies see fit. Now, I recognise from my results that I don't know what happens between the value of 0 and 2000. So I'd like to do a bit more on that. There's maybe even more significant benefits to be had in different scenarios. I'd also like to test it on different site layouts. But I feel, as a starting point, if you applied a weighting factor of 2000 on all approaches, you wouldn't go far wrong. You should see significant benefits. Thank you. And does anyone have any questions?